Welcome on the website of Trainings Effect. I'm really happy now because since 2003 I have been helping athletes to improve their performance by doing some mathematical calculations and explain how they could improve their training. But the main problem with that is that my mathematical model is so complex that people actually need to learn a little bit. And I've been thinking of how to create a learning website for a long time now. And I finally have this now up and running. So what do I have up and running? Well, I've got a website where I put in some mathematical models which uses input these 7 icons with values that are really measured from the body. So these are real physiological parameters that can easily be measured. And if I know these 7 parameters, I can predict a lot of things. How well you will perform, when you have to give up, how fast I would recover from a training, and all things like that, just by using logic in some mathematical equations. But these models need some input. And that input is mostly measured by all kinds of devices. Since 2002, I've been trying to interact with all types of tooling. There are lots of different heart rate brands, power sensors, and I even created the model on a Samsung watch so you could calculate it there. But it took so much time to keep this working due to changes in the hardware, changes in the software that talks with the hardware, that I never got to finish it. So I decided to change this all. I will now mainly focus on what the model does, how the mathematics can be used during a training session. And then I can simply open the mat from a web API or for other people to use this mat for themselves. So pretty soon on this website you can just log in and you can do all your calculations for yourself to check if the model works, to try and see if I can use it in my own software or whatever you want. But I am now only trying to focus to describe what happens in the body. And in this first introduction video, I want to keep it very, very simple, but there's a lot of physiological, biochemical knowledge necessary to fully understand. And I will try to explain it every month a little bit more and more in depth with an interaction. Let us just focus on these 7 icons for this first video. And the first icon is a circle around the head. And that is because the Tmax stands for the ability to accelerate. And acceleration is mainly influenced by the coordination between muscles. And this coordination is mostly related with how the nervous system puts signals to these muscles. So the nervous system is the most important part of this parameter. So if we know this value, we know how fast we can accelerate. The next one is the Vmax, and that stands for the maximum power output. When I started with this model, we couldn't always measure power, so the V was originally used as velocity, but nowadays we just use the power output. And the amount of power you can produce during an exercise is very much related with how strong your muscles are. So that's why the circle is around the muscles. So Tmax to accelerate combined with the Vmax, we can describe the first part of a maximum performance quite well already. Then, if we go on a little bit longer, we will see that the performance will decrease due to fatigue. And we have multiple forms of fatigue. And this first one, fatigue 1, is the ability to cope with muscle pain. And everybody knows that, of course, that if you're exercising like 40, 60 seconds on a very high level, you sometimes get so much pain in your muscle, and it can be just one muscle and the rest of the body doesn't feel that tired. And that type of fatigue that you just have to give up due to the pain in your muscles is called fatigue 1. And this is a very important aspect of the TREFF model to describe the different forms of these fatigues. And the second one, we call fatigue 2, is basically the amount of carbs that you can store in your body. Because during a longer exercise, for example running a marathon, we often see that people after 30 kilometers of running suddenly get an enormous drop in performance. And this fatigue people also call the man with the hammer effect, that you just can't go on anymore because you didn't eat enough and actually went too fast in the first part of the race. This is the only parameter that I cannot really describe in how well it will change in the future, because it's mainly related with your diet. The next form of fatigue is called the cardiovascular fatigue, fatigue 3. And this is very simple. During an exercise, you sometimes start to breathe that heavily that you just can't keep up with the pace. And that's because, the heart-lung system has to work so hard that it just can't give up. Oh, that was backwards. We need to go forwards. So, forwards. The next one is VT2, also called the secondary ventricular threshold. And this is the speed or power limit where if you go above it, you very soon will get out of breath. So inside a muscle, the way we create energy is somehow disturbed that we can't keep a steady state anymore. This needs a lot of explanation, but I will come up on that later on in other videos. And the last one is called the VT1, or also the first ventilatory threshold. And this is also a speed power limit. And if you go above this limit, you will find out that it's not easy anymore to speak with somebody. Your breathing actually goes a little bit faster above this speed. And this is the optimum speed to do the burning of fats in your body. So that's why I put a circle on the fat on the stomach. But it is very important to know that this is not the optimum speed to lose weight. It's just the optimum speed where the most fats are burned. And these are only 7 parameters that can describe a whole lot of the whole body. But my model uses a couple of other parameters as well, but these parameters are not really interested to train on. So I'm not focusing on all of these parameters, but these are just tools to make the model fit on your personal performance. It has something to do with the volumes, distributions, how heavy you are, how fast your cardiovascular system is up and running, what the size is of your heart, and things like that. And I will describe all these type of parameters and things later on a lot more in detail. But before I can really tell what and how my mathematical model works, I will focus the next video, and I hope I can do that in more or less in a month, just to describe what mathematical models are and how we can use them in the sports by an example of somebody throwing a bullet during athletics. So I really hope you will watch that video pretty soon.